Okay, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Okay, my name is Sir Fauzi Bin Ismail. Student ID 2023X73922. Okay, today I want to do a simulation of servo motor using Arduino IDE software. Okay, I'm using the serial monitor to perform this simulation. Okay. What is this simulation for? Okay, this simulation is to simulate the motion control of an actuator such as servo motor using an ESP32. Okay, the system uses a rotary encoder to track position along with push button and LED to represent various functions of the motor. Okay. First of all, the program begins by assigning an input and output pins for buttons, LED and encoder channel. It also set up an serial communication and initialize system states. Initialize system state interrupts are used to monitor change from the encoder to update the motor position in real time. Okay, let's introduce the input and output. Okay, there's a there's 6 input and there's 5 there's 6 input and there's 5 output. Which is the first input is start button, forward button, backward button, reset button, encoder A and encoder B. Okay, encoder A, encoder B. We use the encoder A, encoder B to control the position, and then the start button is to start the motor, and the reset button was to reset the cycle, and the forward and backward button is to move the motor manual job. Okay, now for the output is the run LED, which indicates that motor is running. Origin LED, second output is origin LED, which is indicate that the position of the motor is at origin, which is 0, and the third output is the count LED, which is indicate that the cycle is complete, and the direction LED, which is indicate that the direction of the motor are going forward, and there's a PWM LED, which is also indicate that there's a power in the motor. So okay, for my task, I got the task number E, which is to do a 4 cycle of this simulation. Okay, first of all, to start the simulation, we need to press the button start. Okay, as you can see, the origin LED was turned on because right now the motor is at origin position, so we push start, and then if you can see the direction LED and the PWM LED was turned on, just because that there's no backward motion, because the position was at origin, so they only move forward, and then the PWM LED was indicate that there's a power, there's a pulse. There's a pulse that this motor receive. Okay, so how do we control the position? How do we simulate the position? Which is you use the encoder A and encoder B. Okay, we need to push this button to move the motor forward. Okay, example like this. Sorry. Okay, as you can see. Okay, as you can see, the position is increased, and there's a checkpoint that I put, which is 40 in this cycle. So the first checkpoint will arrive when as you can see, it print that reach first stop, which is the first checkpoint, is 40. And then the cycle is to move on until 80 and then back to origin. So we move again to 80. Okay, as you can see, they reach the second stop. Okay, and then what we do is we need to move backward. So if you move backward, as you can see, the direction LED was turned off. Let's go backward. Okay, until origin. The origin is 0. Okay, as you can see, wait. Okay, sorry. Okay, and then we reach the origin. As you can see, the simulator, there's a print that indicate that cycle is complete, which is 1/4. So we need to do 3 more cycle, just like I did do just now, to complete all the cycles. Okay, let's try. As you can see, this cycle complete. Okay, let's go again. Okay, first checkpoint. Okay, second checkpoint, then we back again. Okay, as you can see, the second cycle is complete, and then we move again to do a third cycle, and the total cycle is 4. So yeah, it's a little bit exhausting, but totally fast. Okay, Okay, and then we move backward again. As you can see, the LED direction LED was turned off again. If we go backward, and if you go forward like this, you see that the direction LED was turned on. And then we go origin for now only 3/4, so we need to go only one time again. See, okay, first checkpoint, second checkpoint, and we go backward. Okay, a little bit more. Yeah, and then we complete the cycle. As you can see, cycle complete 4/4. So there's a print in accelerometer that wrote all 4 cycles are complete, and then the position also was back to the origin, and as you can see, the LED count LED was turned on because it indicate that the cycle was complete and the motor was turned off. You can see PWM was turned off and run LED also was turned off. Then if you want to to go again to reset the cycle, you just push the reset button. As you can see, you push the reset button. You can see the serial print right counter and position are reset. So if you want to start again the loop, we just push the start button again, and then yeah, the motor is running again. So you can just do the loop, move forward the motor. Okay. Or one more, if you want to, let's say, reset, and if you want to manually move the motor, you can use this button, which is forward button. And then you can, you see the direction button is on because the motor is forward. As you can see in the serial motor, yes, the motor jog forward. And then if you want to go backward, you can push the backward button, which is this one. Okay, and you can see that the direction button was turned off, and the serial print monitor says manual jog backward. Okay, and then we move the reset again to back to origin. Okay, that's all from me for the simulation. Thank you very much.